We are busy with topic 15, the theorem of Pythagoras. We are looking specifically at Pythagoras theorem and the sides of a triangle, and we are continuing with exercise 15.3. We are looking at number 4. We are given some of the lengths, and what we need to do is to calculate, giving the reasons, the value of x in the first place. So here we find x. So now the first thing that I see is this blue line together with this red line, and this black line forms a triangle, triangle BDE. And we have a problem here. We can't use that because here we also have a missing value y. So we only have one value of the three side lengths. If we have two of the three side lengths, we probably would be able to calculate the third one in the triangle, especially if we have a 90-degree right angle triangle. So therefore, let's try this triangle, triangle ABE. Here we have now a side length of 20, a side length of 15, and the missing value of x. So now we have something to work with because there's only one missing value. So now since we have a 90-degree triangle, we may use Pythagoras, which states, find the longest side, the side opposite the 90-degree angle, square it. So we take the longest side, we square it, and that is equal to the two shorter sides, their squares added up. So it's equal to the... Okay, now we know we actually have convention. Usually we would first write this actually as opposite big A, we have small a, and then opposite big E, we have small e, and opposite big B, we have small b. So actually we would firstly write it as a squared equals e squared plus b squared. And our reason, remember they asked for reasons, is Pythagoras. So now that we have that, we are allowed to substitute. So into the place of a we have x, into the place of e we have 15, so it's 15 squared, and into the place of b we have 20, so it's 20 squared. So now we can simplify, so x squared equals, what is 15 times 15? Yes, it's 225. Okay, and what is 20 times 20? Yeah, 400. So now therefore x squared is equal to 625. But we are not interested in x squared, we are interested in x. The opposite of a square is in fact a square root. So we can take the square root on the left, and the square root and the square cancel, so that we only remain with x, which we want. But now what we do on the left, we do on the right. So now the question is, what times what gives 625? Yes, the answer is 25 times 25. So since we have square root, we need to keep one of our 25. So the answer is in fact x equals 25 units. So we know therefore x is equal to 25 units. Okay, so now that we have tackled B, tackled A rather, let's focus on B. Now we need the value of y. But now since we found the value of x, that makes it easy to use triangle EBD. Because we have x is 25, we have this value of 7, so y is the only missing one in terms of the side lengths of that triangle. And we have a 90-degree angle, so we can again apply Pythagoras. So in this case, we now have opposite this D, big angle D, we will have small side D. Opposite big angle E, we have small side E. Opposite big angle B, we have small side B. So now we can use Pythagoras. We find the hypotenuse, the longest side, the one opposite the 90-degree angle. So that will be d squared. So d squared equals the sum of the squares of the two shorter sides, which is b squared and e squared. And this is according to Mr. Pythagoras. So now the next step is to simply substitute. So we replace d with 25. So we have to square 25. Similarly, we replace b with 7. So we have to square 7. Plus e is the one we don't know. So we leave it as e squared. Now our strategy is we need to swim across the river so that all the numbers are together, all the variables are together. So we have 25 squared, the 7 squared, swim across the river, the sign changed now to negative 7 squared, and that is equal to e squared. So we can simplify now a bit. What is 25 times 25? Yes, it's 625. We subtract 7 squared. What's 7 times 7? It is 49. So that is all equal to e squared. So now what's 625 minus 49? 476, I believe. So e squared is 400. Was it 576? Rather 576. So now we don't want e squared, we want e. Opposite of a square is a square root, so that we simply have e as they cancel. What we do to the left, yes you bet, we do it to the right. So now the question is, what times what will give us 576? (24 times 24). So we keep one of the 24. So our answer is 24 units. So I'm going to ask you to attempt now number C, where you have to calculate Z on your own. See if you can do it. Okay, so the first hint I will give you for those that are maybe still struggling a little bit to get started is here Z. We already had y equals 24, we have 26, so we have two of the three sides, only one missing side, and we have our 90-degree triangle, so we can use Pythagoras in triangle BDC. So that's the triangle that you will use. So for those still struggling, the next hint is use your convention. Look opposite big angles, give the small, assign the small letters. So opposite big angle B, we will have small letter B. Opposite big angle D, capital angle D, we will have small d. Opposite capital C, we have small c. So for those still a bit unsure, hint, next step is apply Pythagoras. When applying Pythagoras, next hint, what do we look out for? The longest side. Where do we find it? Opposite the 90-degree angle. Okay, so what does Pythagoras say? Take that side, the one opposite the 90-degree angle, the longest one, square it. And now it's equal to the sum of the squares of the shortest sides, which is d squared and c squared. Remember your reason, Pythagoras. Next hint, you're still struggling. Replace the letters or substitute them with the values. So do we know the value of b? Yes, it's 26. So we have to square 26. Do we know the value of d? No, it's z. So yes, in fact we know z, but we don't know the number value. So we replace d with z. So it's z squared plus, do we know c? Yes, 24. So we have to square that. Okay, so now that you have that, you can either swim across the river, or you could first just simplify and then swim across the river. Okay, previously we have shown how to swim first through the river. So this one, I'm maybe going to take the other approach. So what's 26 times 26? 676. What is 24 times 24? 576. Strategy, swim across the river. So that Z is on the one side, the numbers on the other. So we have 7, 7, 6, 6, 7, 6 rather. Swim across the river, it becomes minus 576 equals Z squared. So the difference here is 100. So Z squared is simply 100. Next step. What's the opposite of a square? Square root. So that the root and the square cancel. So that we have simply Z. What we do to the left, we do to the right. What times what gives 100? Aha, that's an easy one. 10 times 10. Keep one of the tens. So in fact, Z is simply equal to 10 units. Okay, so now we are number D. We have to name one. We need to name one trapezium and give reasons for our answer. Now, if you look at B, C, D, E, I believe that is a trapezium. Remember, for a trapezium, we need one pair of parallel lines. So now, I would say that we have a pair of parallel lines here. Why do I say that? Because we have the Z shape. So if we go here, we follow the red, we go here, I see the Z shape. Because remember, what is a Z shape? Z shape is when you have a transversal. So transversal cut through the parallel lines. So we have a transversal, the red line. The angles are the same on opposite sides of the transversal and inside the other two lines. Now so we call this Z shape alternating angles. If two lines are parallel, then alternating angles are equal. The opposite also though apply. If alternating angles are equal, then they lay within two parallel lines. So we can say BCDE is our trapezium. So BCDE is trapezium. Reason is that angle EDB, EDB equals to CBD. Which are alternating angles. So alternating angles. So there are alternating angles that are equal. Therefore, we know that BE is parallel to CD.